Alright, last problem, the second number 7, calling it number 8. We're given three parametric equations. We're told that it is modeling the movement of a particle, or three particles, A, B, and C. And we're supposed to sketch the graph of each and indicate the starting point, the orientation, and the ending point. We're supposed to eliminate the parameter for each and write the equations in rectangular form. And finally, we're supposed to write a brief statement about how the parametric equations differ from each other. So let's start with our red equations first. And now, in each of these cases, I'm actually going to eliminate the parameter first because that's what I want to do. So I'm going to solve for x in that first equation, and solve for t rather, and I'm just going to get x minus 1 equals t, and I'm going to substitute that in for y now to get y equals 2 times t, which is x minus 1, plus 5. Simplifying it again, y equals 2x minus 2 plus 5 is plus 3. So I know I'm dealing with a nice linear equation here. Y-intercept at 3 and a slope of 2x. But also, let's just plug some t values in and see what we get. So plug in 0, we get an x equals 0 plus 1. So the first x value we get is 1. Get our t value, plug in 0 to y, we're going to get 5. So we get the point 1, comma, 5. So we're starting up here. Let's go ahead and find our ending point as well. What does my dog want? She needed to go pee. I let her out. Don't worry, folks. Alright, let's find our ending point as well. So plug in 6 for t into x and y. So our x value is going to be 7. And our y value is going to be 6 times 2 is 12, plus 5 is 17. So we're going to get that ending point all the way over there. X value 7, y value 17. And our orientation is going to be like that. We're starting down here with that big fat point that I drew, and we're going up. And I could test more points, but I know that orientation is going to stay true. I'm going to start here and go that way because these are just linear equations. So I know how linear equations act, so I know that that is going to be the case. Alright, now let's look at this second scenario, the green set of equations. And let's do the same thing real quick. Let's just go ahead and substitute in. So notice that x equals sine t, and we have a sine t in our y equation. So substitute that in, we'll get y equals 2x plus 3. So note, so far, it's the same equation that we just did. But this is going to behave a little differently. So I am going to substitute in some t values to figure out the behavior of this equation. Let's figure out where I'm going to start though. X equals 0. X equals sine of 0. Well, jump back to the unit circle. The sine of 0, sine is our y values, sine of 0 is 0. So I'm starting at the origin. And since sine of 0 is 0, 2 times the sine of 0 is 0. So y is going to be just the value plus 3. So go 1, 2, 3, x was 0, y is 3. So I'm starting right here. Now we're going to go all the way through the unit circle, 0 to 2 pi. So think about what sine's going to do around there at the key points. Well, it's 0 there, and then it's going to go up to pi over 2, where the value of sine is at its maximum, and it is 1. So substitute those values in. X equals 1, and so we're now at an x value of 1. And y is going to equal, since sine is equal to 1 at pi over 2, 2 times 1 is 1. 2 times 1 is 2, plus 3 is 5. So I'm going to go up to 1, 2, 3, 4, 5. So I'm just going up 2. Now think about what happens. I'm now back down where sine is 0. So I'm going to go back to that same point. Weird. And now at 3 pi over 2, sine is -1. And so I am now going to be at the x value, -1, and the y value, +1. So now I'm right here. And then back at 2 pi again, I'm back where I started, back in the middle. So again, it's going to be a linear equation, the same linear equation. It looks like that. But if you were to trace out the orientation, it starts at that point in the middle, goes up to its max, then it goes back to its starting point, and then it goes to its min, and then it goes back and finishes where it started, looking something like that. And that makes sense because the unit circle goes from from 0 to max to 0 to min to 0. So 0 starting in the middle, up to its max at 1, blah, blah, blah. You get it. Kind of cool. Alright, let's do this last one now. Again, it might look scary because it's all like exponential and stuff, but let's just eliminate the parameter. So solve that top equation for something that you can substitute in. I'm going to solve it as x minus 1 equals 3 to the negative t, and so y is going to equal 2 times x minus 1 plus 3. And now that I'm looking at this, I think we actually wanted x equals 3 to the negative t, not the 3 to the negative t plus 1, because this is going to give us a different equation. This is going to give us y equals 2x plus 1, and we really wanted y equals 2x plus 3, so a little bit of mistake there. But let's think about how this is going to look. So either way, we're dealing with the same slope as before as we wanted, but I guess we have a different y-intercept now, whatever. But since we're not given anything about t, it's going to go on forever. So there's not really any starting point, but it's going to start down at negative infinity and run up forever. Oh wait, or is it? Because think about this, t is negative. So at t equals 0, we're going to end up right over here when x is 2 and y is 5. But then think about this. When you put in t equals 1, x is going to be 4. And when I say 4, I mean just kidding. It's way too late, and I'm glad this is the last problem. X equals 3 to the negative, when you plug in t as 1, you get -1 plus 1. 3 to the -1 is just 1/3 plus 1, so x equals 4/3 instead of the 2 that we just had. So our orientation is that way. And so if we restricted our domain, we could have gotten a similar graph to the green and the red one. But the point is, on all three of these parameterizations, we get the same line, other than this last one where the that one shouldn't have been there, got messed it up. But the idea is we can get the same path, but we can model different patterns, so different movements of the particle and different speeds as well.